Currently, amateur radio satellite activity is on VHF, UHF and SHF. Format 2 being for low Earth orbit LEO satellites and SHF for Qatar Oscar 100 geostationary amateur radio satellite. But there was an era when there was satellite activity on 10 meter or 28 megahertz. Though I don't think any such transponder is currently active. AMSAT OSC-7, which was launched on November 15, 1974 and still continues to be partially active, is one of the satellites which was active on 10 meter band. It had a Mode A transponder with 145.850 to 950 MHz uplink and 29.400 to 500 MHz downlink, and Mode B transponder with 432.180 to 120 MHz uplink and 145.920 to 980 MHz downlink. These are linear SSB/CW inverting transponders. In addition, it had 29.500 and 145.700 MHz beacons. There was also a 2304.1 MHz, which was never turned on because of international treaty constraints. In 1981, AO7 had become non-operational due to battery failure. But surprisingly, in 2002, one of the shorted batteries became an open circuit and the spacecraft transponder was able to run on solar panels. Yet, it would not be usable in eclipse. When continuously illuminated, it could alternate between A and B modes every 24 hours. A look at AMSAT Live Oscar satellite status page tells me that only Mode B is operational currently, that is a UV linear transponder with uplink on UHF and downlink on VHF. It is interesting to note that the 432 MHz uplink for AO7 was designed before implementation of the 435 to 438 MHz satellite subband. Operation in the United States is currently grandfathered under a waiver from the FCC. Another instance of 10 meter activity by a satellite or rather a spacecraft was from Juno, which was on its way to Jupiter. Global amateur radio community had participated in a challenge during its Earth flyby over a decade back. Earth flyby was to give Juno a gravity assist to send it to Jupiter. View2JOS had posted a QSL card confirming his participation in the event. The event was on 9th October 2013 when over 1,400 amateur radio operators around the world transmitted HI in Morse code repeatedly in unison. Simultaneous global transmissions were needed to ensure that the signal reaches the spacecraft. It was also a way to engage the global community in the space program. Radio amateurs used 2 web pages provided by NASA to synchronize their transmissions. NASA could extract the Morse code signals transmitted on 28 MHz and decode it after sieving out the background noise. The image from NASA website shows decoded signals. This is the accompanying video clip from NASA website. The event was termed High Juno Experiment and it was a coordinated effort of NASA and the global amateur radio community.